Start with the name of Allah, the great, merciful and kind. My name is Mohammed Usman Jamali from BSCS Batch 2K18, Sindh University, Larkana campus. So, in this video, we learn about numerical analysis and some topic of numerical analysis. So, these are agenda. Today, we will discuss about what is numerical analysis, bisection method, working rules of bisection method, and example of bisection method, rounding of error, rounding to significant error, truncation error, and example of truncation error. The field of numeric analysis predates the invention of modern computers by many centuries. Linear interruption was already in use more than 2000 years ago. Numerical analysis. Numerical analysis is the branch of mathematics that deal with the development and use of numerical methods for solving problems. The overall goal of the field of numerical analysis is the design and analysis of techniques to give approximate but accurate solutions to hard problems. It is the study of algorithms that use numerical approximation for the problem of mathematical analysis. So why do we study numerical analysis? Numerical analysis aims to provide computational algorithms to solve problems that may otherwise be not practically solvable in real life. In short, this is the study of how the computer would solve a problem. So we study numerical analysis, get to know how fast errors cause problems to find better algorithms that cause less errors. Some usage of numerical analysis. Usually used in computer science for root algorithms. Second point, it is used to determine profit and loss in the company. Used for multidimensional root finding, solving practical technical problems using scientific and mathematical tools, network simulation, train and traffic signal, and also use weather prediction. Some types of numerical method or numerical analysis. Bisection method. First one is the bisection method, Newton-Raphson method, iteration method, Newton forward interpolation formula, Newton's backward interpolation formula, this setting method, and rule fitting. So next topic is bisection method. The bisection method is a root finding method that applies to any continuous function for which one knows two values with opposite sign. First rule of bisection method: find 2 points, say A and B, such that less than B, A less than B, and f of A multiply f of B less than 0. So 2 points, you can see here A and B. So these are 2 points. So these are both points we will find. The root that we need to find will lie between positive and negative value. So A point is a negative and B point is a positive. Second rule of bisection method is find the midpoint of A and B. So this is the formula, this is the definition for find the midpoint, A plus B upon 2. And third one is the find the f of x1. So if f of x1 value is positive, then replace b is equal to f of x. If value is negative, then replace a is equal to x1. Rounding off. So rounding off is the difference between a rounded off numerical number and the actual value. Rounding means making a number simpler but keep its values close to what it was. The result is less accurate but easier to use. For example, 73 rounded to the nearest 10 is 70 because 73 is closer to 70 than to 80. Here the general rule of rounding. If the number you are rounding is followed by 5, 6, 7, 8, or 9, then round the number up. For example, 38 rounded to the nearest 10 is 40. Second rule is that if the number you are rounding is followed by 0, 1, 2, 3, or 4, round the number down. For example, 33 rounded to the nearest 10 is 30. Rounding of error. A rounding of error, also called rounding error. Exact rounding of inspiring mathematical function is difficult because the number of extra digits that need to be calculated to resolve whether to round up or down cannot be known in advance. So, so find the error, apply the formula or definition of error. So this is the formula, this is the definition of find the error. Actual value minus approximate value. So here is an example. X star is equal to E is equal to 2.7182818246. So that is called exponential constant, and this is the actual or true value of exponential constant. So here X star is used for true value. So, so now we are going to round off this number into two decimals. So x is equal to 2.72. So this number is greater than 5, so we round up. So here the result is 2.74. So now find the error. So we can find the error with the help of this definition, this formula. E is equal to true value minus approximate value. So here is the real value is 2.7182818246. 2.72. So this is the round of error. Significant figure. Significant figure. Significant figure. Number of significant figures indicates precision. Significant digits of a number of those that can be used within confidence. The number of certain digits plus one estimated digit. The term significant figures refers to the number of important single digits 0 through 9 inclusive in the coefficient of an expression in scientific notation. Significant figures in a number use the following three rules. So all non-zero digits are always significant. If you have zero at the start or end, it does not count as significant. Zeros are only significant if the number contains a decimal point zero between two digits, like 0.1304. That's count. So some example of significant figures. So 42362. So here is the all non-zero number. So so here five significant numbers. 0 after 2.0. So 0 after a decimal point count. So 2. So here also 2 significant. So here 2 significant. 9900. So only two significant in this case because the zero is no decimal. 445, 44205, there is a capital zero which means it counts. So here is the five significant number. 505, only the five counts. So here is the one significant number. Tricky one, but significant notation help make the zero at the in noticeable. There are five significant truncation error. Truncation error. Basically, truncation error is something reduced. Shortening something by removing part of it. It can also mean that it can also mean the state of having been truncated. Truncation can involve the removal of the beginning of something, the ending of it, the top of it, or another part of it. To shorten or reduce, to shorten a number by dropping one or more digits after the decimal, to replace the edge of a crystal with, with a plain text. I have a number 10.234985413434 After 10, after 10, here is the huge number. Now I am going to show only 10 digits. So 10.23498541. So I will show this number and 3 point and 34346. So these numbers neglected from here. So this kind of type of method fitting a number is called truncated. Truncated. So truncation error is the difference between a truncated value and the actual value. A truncated value, a truncated quantity is represented by a numerical with a fixed number of a low digit. Consider the speed of light in a vacuum. The official value is 2999792 meters per second. So truncating it to decimal digit. So truncating it to decimal place then 2.99 into 10 power 10. The truncation error is the difference between the actual value and the truncated value or truncated value. So expressed properly in scientific notation, it is the 7.92458 into 10 power 5. So thank you very much. I hope you understand